Hi, and welcome to this video. In this video, we're given a root tree. Pretty straightforward, and all we need to do is count the number of nodes. Now, you might think that we need to iterate through and then create like a variable, put a count in the variable, and yes, we do essentially need to do that, but you don't need a variable to do so. Let's see how. So what you need to do is you need to create another function. Private int recursive, or you can give it a better name like count or node or tree or something better than recursive. Tree node root. Now when you go into this recursive function, what we're doing is that we're iterating through the tree like you would in any other type of tree node problem. So we have two scenarios. Either we have root equal to null, in which we would return 0 because there is no nodes if the root is null, and otherwise we'll return recursive of root dot left plus recursive of root dot right plus 1. So what we did is we're saying that we're going to count the number of nodes from the specific point in the tree. So you're saying if root equals to null, we return 0, because that means there's no nodes either now, where we're currently at, or left or right. So that's why we return 0. Otherwise, what we're going to do is we're going to return the recursive of the left side. So we're going to count how many nodes are on the left side. The recursive of the right side, so we're going to count how many nodes are on the right side. And then we're going to add 1 for the current node we're at. And what this will do is that it will return at the end the total number of nodes. And the reason is because, let me, okay. So let's say that you have this node A, it's connected to B and C, connected to D and E, and C is connected to F and G. So what it will do is it will first go to this node because that's the node we passed in, and we're going to first add 1, and then we're going to recursive to B, and we're going to recursive to C. In B, this is the node passed in, it's not equal to null, so we're going to add the number of nodes in D, number of rows in E, plus 1 for the current node we're at. And what that will do is that once we calculate this, like this BDE, that's what's going to be in A's root dot left. So as you can see, we'll get 3 here. And then on the right side, we'll also get 3. So we'll go to this top node and we'll say 3 plus 1, which is 7. So that's how this recursive function will work. But we obviously need one last step inside this method. We're going to do recursive of root. You could also just take this, put it in here, change this to count nodes, change this to count nodes, and also remove the necessity of having a second function. But if you do prefer having a separate function, then you're welcome to do so. But I hope this video was helpful, and see you in the next video.